Okay, and so welcome back, everyone, or welcome back, Ricard, to today's class on the topic of quadratic functions. And so uh, let's just get right into it. And so the introduction to quadratic functions is that the definition is that a quadratic function is a polynomial function of the form fx equals ax squared plus bx plus c, where a is not equal to 0. And another key thing to note is that the graph of a quadratic function is a parabola. So what this means is that a quadratic function comes from the fact that the highest degree is a degree of 2, hence the ax to the power of 2. And also, the fact that the graph is called a parabola is because we are given a xy plane like such, and then we are given a quadratic function that looks like this, and we call this shape a parabola. And so this smooth shape that kind of looks like a bowl is called a parabola. But the parabola can be two types. One which opens up, that opens upwards. So there's a minimum, and then there are infinite, and there's no maximum because the y value can increase until infinity. The other type of a parabola is a parabola that opens downwards, meaning that it kind of fans out through the down direction. And so a characteristic is that a downwards opening parabola has a maximum value, but then does not have a minimum value because the y value can go until negative infinity. And so we'll take a look uh, at what kind of quadratic functions have what kinds of parabolas. And so we'll move on to our first concept of today on which is solving quadratic functions. And so solutions can be found using factoring. The quad can be used through multiple methods such as factoring or the quadratic formula shown on the screen here, or by completing the square. And so what this means is that factoring usually means if we are given a equation in the form of a fully solved quadratic function, then we can change it or rewrite it in a way that has, for example, hmm, uh, what coefficient? If we say it's alpha x plus beta times rho x plus, uh, let's say, for example, theta. And so we can re-express it into a multiple of two linear equations in order to get a quadratic equation. And also, if we are given uh, a quadratic function, but it's difficult to factor and it's difficult to kind of uh, really quickly understand, okay, what values it can be factored into, then we can utilize the quadratic formula shown here in order to find direct values of x that satisfy the quadratic function. And so the quadratic formula you would have to memorize, which is x equals negative b plus minus root b squared minus 4ac, excuse me, over 2a. Yeah. And so this is something that you will have to memorize. It's a very important formula. And so I do advise you memorizing it well. And also the final kind will be completing the square, which is the opposite of what we just took a look at. So instead of being given the actual full formula, if we are just given the factored version already, then we can just either complete the square set in here, depending on what the question is asking for, we can find values of x that satisfy this equation. And so we just took a brief look at the concepts. And so we'll take a look now at how this can be utilized through example questions. And so the first example question states, what are the solutions to the quadratic function 2x squared minus 4x minus 48 equals 0? And so we're given a quadratic function, right, as seen here, excuse me. And so this can be said as, let me just write it again next to it. And so from here, if we have to find solutions to the quadratic function, it means we have to find values of x that satisfy the equation. And you can see that this entire equation must equal to 0. And therefore, we have to find values of x that make this equation equal to 0. And so first thing we can kind of see right before we do anything is that each coefficient is a multiple of 2. And so we can divide by 2 to simplify it and to make the equation easier for us to analyze. And so if we divide each coefficient by 2, then we get x squared minus 2x minus 24 equals 0. Okay, now from here, there are two ways to solve for the solutions. We'll take a look at both. So first one, we can utilize the quadratic formula. And so if we were to do this, let's say use quadratic formula, then we can say that because the quadratic formula, if you recall, is x equals negative b plus minus.
Plus minus square root of b square minus 4ac by 2a.
Yep, that is correct. Great job. And so, yeah, if you recall, a is the coefficient of the x squared, b is the coefficient of just x, and c is the coefficient or the constant within the quadratic function. And so we just plug in the values directly into it to find it equals negative b is just plus 2 plus minus root b squared is 4, and then a times c was just negative 24, but then if we multiply negative 4 with 1 times negative 24, we get 96. And so we add 96 over, and a was just 1, and so 2a will be 2. And therefore, we can solve it further to get 2 plus minus root 100, which
Square
is,
root of 100 is 10.
yeah. And so we get plus minus 10 over 2. And so this will equal so if it was plus, then you could get 12 over 2. Or if you did from the minus, you can get negative 8 over 2. And so you can if you solve these, you get 6
6 and
and
negative 4, sir.
4. Yeah, that is correct. And so using the quadratic formula, you can directly find the answer or the solutions to the quadratic function. And so from here, we've found that it is equal to 6 and negative 4, which makes sense because from a quadratic formula, you're able to get two values of x's in order to that work with the solution to solve the function. And so hmm, this is one way to solve, but then there's another way to solve, which is just factoring. And so for some students, factoring, if you're not used to doing it frequently, it may be more difficult than just memorizing the quadratic formula. But then the good thing about getting used to quickly factoring quadratic functions is that you can save a lot more time compared to using the quadratic formula. And so here's some tips for factoring well. And so, first of all, you can see that we simplified the coefficients so that the x squared has a coefficient of just 1. And so there's nothing in front. And so we can say that the function can be written in this form. And so we're not sure what the constant values we can add to the end are, but then we can know that the coefficients of the x's will be always 1 because the coefficient of x squared is also already 1. So this is our starting point. And so we have two constants, a and b. I'll erase this part for some more space. And so if we have a and b, we can kind of take a look at how this will be solved if we solve it through. So you get x squared plus ax and bx exist, and so it will be a plus b x plus a times b, so ab. And so already you can see that the multiple or the product of the constants would have to equal negative 24. And so, and also the addition of the two constants will have to equal negative 2. And so, uh,
Negative 6 and 4, sir.
yes, that is correct. Very quick, actually. Wow, great job. And so you can say that, knowing those facts, we can say that it can be rewritten as A being negative 6 and B being positive 4. And so you can think of it as if the two constants have to be multi when they're multiplied together, they must equal 24 or negative 24. We just think of constants that can work with this. So we can say that maybe it's 1 and 24, negative 1 and 24, or negative 12 and 12, negative 3 and 8, negative 4 and 6, and the opposite, and they flips so that we get 6 or 4, 8 or 3, and so from here. And then also the negatives can be on either value. So if we think about every possibility of this happening, we then take a look at if these two constants are added, they must equal to negative 2. And so from here, we find values that if they're added, when they have opposite signs, what would equal to 2? And the only possible answer will be 6 and 4, with the negative being on the 6, not the 4. And so this is a way to kind of quickly find the factored version of our quadratic function. And from here, we know that this equation that we just factored must still equal 0. And so from here, we can find x values that equal 0 easily. So x could equal 6 or could equal negative 4 in order to be a solution to the quadratic function. And so these are two ways to solve this kind of quadratic function problems. And so any questions for this one?
No, sir, not any.
Okay, great. Then I think we can move on. And so as such, solution is the same. And tips is to always check if the equation can be simplified by dividing by a common factor. Look for pairs that multiply to the constant term and add to the middle when factoring. And so we can take a look at another practice question, but just to save time, we can move on to our next concept because uh, it is quite similar. So maybe we'll just take a look at the solution automatically. Uh, and so just reading the problem from the quadratic function 2x squared minus 2x minus 40 equals 0. The sum of the solutions is expressed as b, and the product of the solutions is expressed as c. What is the value of c plus b? And so right before we move in, you could utilize this solution written here, which solves for the solutions themselves automatically. Excuse me. Which is a very valid solution and method of solving this kind of question. But then, if you want to save just a little bit more time, then you can actually, if you recall my previous solution, we saw that uh, when there is when a equation is factored and solved again. You can actually analyze the full quadratic function in order to find sums and products of the solutions. As because we know that the coefficient of the x value will be a sum of the solutions, and the constant will be a product of the solutions, which is the exactly what we are asked to find. However, a key thing to note is that uh, for this function and for other functions, in the case that the coefficient is equal to, if the coefficient of the x squared value is not 1, but another value, then you can either divide by the coefficient of the x squared so that you can get a x squared value of 1 so that you can utilize the exact values in order to find the sums and the products. And so if we do this for this function, then 2x squared minus 2x minus 40 equals 0 can be rewritten. If we divide everything by 2 so that our x squared coefficient is 1, then we get x squared minus x minus 20 equals 0. And so from here, we can see that the sum of the solutions will be our a plus b. However, in the question's sake, we will say that the sum is the variable b. The sum of the two solutions is -1, and the product of the two solutions is equal to -20. And so if we do this, mm, excuse me. Okay. Uh, slight detail. Miss, excuse me. The sum of the values wouldn't be -1, but rather +1. The reason being is that uh, this -1 value is, in our case, in our example, a plus b. However, the sum of the solutions will be not a plus b, but -a minus b. So this is the value we have to find, not a plus b. And so we negate the coefficient of the x value so that it's, instead of -1, we get +1 for our sum of solutions. And so here we found the two values of b and c that the question asked, and then we just sum them up so that we get a final answer of -19. Yeah. And so two methods to solving this kind of question. First one here, second one here. And so you can just choose any solution and method that you're more comfortable with and just practice those. But I do recommend trying both ways, finding and then deciding yourself on which one you're more comfortable with. And so any questions regarding this problem?
No, sir.
Okay, great. We can move on now. Oh, yeah. Okay, so our next concept is regarding properties of quadratic functions. And so we are taking a look at different properties. And so until now, we took a look at what's called the standard form of quadratic functions or quadratic equations, which just means the full equation, all solved out, all written throughout. So that, for example, being fx equals ax squared plus bx plus c. However, there's also another form called the vertex form. And the reason behind this, it being called the vertex form, is because through this expression of the quadratic function, we can find the vertex of the parabola that represents the equation. And so what we mean by vertex is that if we had a quadratic function that looked like this, then the lowest point, or in our case, the minimum, will be this this quadratic equation's vertex. And the same is true for the parabolas that open the other way. The maximum here is the point at which there is a maximum value is also called the vertex. And so we are able to find the vertex when it is written in this form. If we take a look here. And so from here, uh, basically you can say that if you take a look at the inside of the square, the x minus h, then uh, we can say that when x is equal to h, let's say for example here, or not here, yeah, we can say it's here. So when x is equal to h, as in such, then we will have this will entire thing will become 0, and then we will get a remaining y value of k. And so therefore, when x is equal to h, there is a maximum, or the vertex is at when y is equal to k. And we can say that the vertex point is h comma k. And so just key things to memorize. So there are standard forms, and also we can re-express them in terms of vertex forms to find vertexes, depending on what the question asks you to find. And another thing is the axis of symmetry. This axis of symmetry is basically the, I guess, invisible line that goes through a parabola, that shows symmetry uh, for each side of the axis itself. And so usually, always the axis goes past the x value at which the vertex exists. The vertex exists. And so for our case, it will be x equals to h being the axis of symmetry. And so another key thing to memorize is uh, which direction the parabola opens, whether it's upwards or downwards, depends on the sign of the coefficient of the x squared value. And so if these two equations were in terms of this standard form, but then a was less than 0 or negative, then the parabola opens downwards. However, if the a value here is positive, then the parabola opens upwards. And so these are just a couple key facts and things to memorize to make your problem solving easier. And so before we move on to practice questions, do you have any questions?
No, sir.
Okay, great. Then we can take a look at example problems. And so our first problem states which shares a correct relationship between the quadratic function and its vertex properties. And so what this means is that we take a look at the answer choices here. The first one, second one, third one, and fourth one, they all show a quadratic function in the vertex form, or another kind of unorganized form. And then it says whether that quadratic equation has a maximum or a minimum, and what the point of the vertex will be. And so before we try to find each vertex point, we can uh, utilize the uh, direction of whether the parabola will open up or open down to see if it has a maximum or minimum. And so first off, the first one, if you take a look, the coefficient will be positive because there's a positive 2 multiplied, and so we'll open upwards. And however, it says there will be a maximum, which cannot be true because when a parabola opens upwards, there can only be a minimum value. Yeah. And so from the beginning, we can cross out our first choice from being the answer. If we take a look at the second equation, we can see that again, the coefficient will be positive for x squared. And it says that correctly, it will have a minimum. And so choice 2 could be an answer. If we take a look at choice 3, uh, this time we are given a negative coefficient for x squared, which means it will open downwards, and that the statement says there will be a minimum, which cannot be true because the in the opposite way, when a parabola opens downwards, there can only be a maximum value, not a minimum, and therefore the third choice is also incorrect. Fourth choice, again, it is negative coefficients, but then it correctly states there will be a maximum. And so we just have to find now the actual vertex values for only two choices. And so if we take a look at choice 2 first, then we can see that it's not in a vertex form. And so we'll change it into it. And so there's multiple ways. But then for me, I would just uh, solve the entire thing through first so that we get a value of 19. So then from here, we group 4 so that we get x squared plus 5x plus 19. And then from here, we rewrite this part of the equation into a equation that is squared. And so if you remember the vertex form, it was fx equals sum a multiplied by x minus h squared plus sum b. And so we're changing this into this form. And so if we're to do this, then first of all, the coefficient at front stays the same as 4. And then we will have x because it is a coefficient of 1. So just x. But then if we were to square this value, and we have to get 5x from it, if we were to solve it through, then if we remember linear equations, if we square a value, then we get x squared plus 2ax plus a squared. And so 2ax would have to equal 5x. And therefore, we can say that a has to be 5 over 2. And so we plug in 5 over 2 within the square. If we are to do this, then the constant value will actually change because 5 over 2 squared will result in 25 over 4. And then this 4, that is the coefficient, will be multiplied to this constant so that we get an extra 25. But we don't want 25 plus 19, we just want 19. And so from the 19 that's already there, that was brought, we add a minus 25 so that we get rid of this extra 25 that results from squaring this value. And so if we're to do that, then our final vertex form of the second equation will come to 4 times x plus 5 over 2 squared minus 6. So from here, we can say that the vertex point will be at when x is equal to negative 5 over 2. So this entire thing would have to be has to equal 0 when we're finding the vertex point. And then the remaining constant that's at the end will be our y value for the vertex point. And so the vertex point will come out to negative 5 over 2 or negative 2.5 and y being negative 6. And so our second statement, if you take a look, is true. You correctly found the vertex point. And so second statement will be the answer. However, we can still take a look at the fourth function or the first statement, excuse me. And we can see that it's already in a vertex form. And so we can very quickly say that the vertex is at when x is equal to negative 4, and when y is equal to, if you look at the constant, negative 1. However, the statement incorrectly says that the vertex point is at positive 4, when in actuality it will be negative 4. And therefore, fourth statement is incorrect. And so, any questions regarding this problem?
No, sir, not at all.
Okay, amazing. And so we can move on to our practice question. And so solution is the same. And then a tip is to identify the sign of A to determine if the vertex is a maximum or minimum first, and then to convert to vertex form to easily find the vertex coordinates. And so, yeah, we can take another look at a practice question. So what is the vertex coordinate of fx equals negative 2x squared plus 8x plus 12? And so, like we did for our previous question, we can change this uh, general form into a vertex form. And so what I usually like to do is to write the coefficient of the x squared first, and then in parentheses, I will group until to include the x squared and the x, so that we get x squared minus 4x. And then we close the parentheses, and then we add the constant at the end. So the same constant of plus 12. Then from here, we have to change this expression into a square. And so if we're to do this, then this becomes the coefficient stays the same at negative 2. And then we have x. And then if you remember, if we square x plus a, we get x squared plus 2ax. And so the constant that we have to add is half of this coefficient. So it would have to be negative 2 that we square. And then if you remember, if we solve this square, we get x squared minus 4x plus 4. And so we want to get rid of this extra plus 4. But before we do that, the plus 4 will be multiplied by this negative 2 so that we get an extra negative 8. But we don't want this extra negative 8. So at the end, we will add another
Positive 8.
positive 8. Yep, correct. To get rid of this negative 8 that we created from going from this expression to a squared expression. And so if we do this, then we can quickly say that 12 plus 8 will result in plus 20, so that we get a x value of 2 and a y value of 20 for our
20.
vertex point. And so our vertex coordinate will be 2 comma 20, which will be our final answer. All right, I think Srikar, you understood well, so we can move on automatically. And so, yep, solution is as such. And then this brings us to our next concept of today, which is graphing quadratic functions. And so some things to remember is that a parabola must feature the axes of symmetry, the y-intercept, as well as the x-intercepts, which are also known as the roots. So what this means is that uh, if we are given a quadratic function, such as this, and we know that a is positive, then we will get a values as such, a parabola as such, for example. And so you may be wondering, and so we now know how to find the vertex point because we already practiced this. However, how do we find the x-intercepts? Well, the x-intercepts are the values, are the solutions to this quadratic function. And so if you remember how we utilize the quadratic formula to find solutions to quadratic functions, that solutions that we gain from quadratic from the quadratic function so excuse me function will be the x-intercepts. And so these are just very basic ideas to remember. And so we'll take a closer look at example questions to get used to this. And so we'll see that which of the following appropriate expression, which is the most appropriate expression for f of x. And so within this example question, we are given a parabola, and as well as the graph version of the parabola, and we have to find from the answer choices what is the correct function for this parabola. And so if you take a close look, then you can see that we are able to find the vertex point, which is here, with a x value of -2 and a y value of +3. And so you can say that if we were to kind of find the quadratic function itself, it will have some kind of coefficient in front. But then because we know the x value for the vertex, we can write it as x plus 2 squared because our vertex was -2, and the y value will be +3 because our y value of the vertex was also +3. And so only thing we don't know is the coefficient in front. However, if you take a look at the answer choices, then you can see that all the coefficients are just +1. And so if we're to, and so we can say that a is equal to just 1. And so if we were to solve through this quadratic function, then we can say it is equal to x squared plus 4x plus 4 plus 3, which is equal to x squared plus 4x plus 7. And so our final answer will be the second choice here, or answer choice B. Uh, right before we move on, there may be questions that have a coefficient value that are different. And so maybe the answer choices have coefficients that are different to each other, in which case we would have to find the coefficient ourselves. And so you can usually do this by by using any point that the parabola goes through that is not the vertex. And so for our case, we can actually utilize the y-intercept, the point here, which gives us an easier value to find the coefficient. And so the y-intercept is a coordinate of 0, comma 7. And so we can plug this equation into here so that we get 7 equals a 0 plus 2 squared plus 3. And so this will equal 0 plus 2 is just 2. If we square that, we get 4a plus 3. And so we can move around stuff to get 4a equals 4 and a equals 1. And so you can also directly find the coefficient itself using another point other than the vertex. And so that's Any questions?
No, sir.
Okay, great. Then I think we can move on to our next practice problem. And so the solution is the same. As the tips is to use the vertex form and substitute known points to find A, and then check the graph's direction based on the vertex and given points. And so sometimes you might want to check whether the coefficient is positive or negative. For that, just check the direction in which the parabola opens up, and you'll easily understand. And so our next problem, it states which of the following functions does not lie in the third quadrant of the xy plane. And so if you remember, we briefly touched on the subject of quadrants a couple classes back from another practice question. But just to refresh your memory, the quadrants are just four areas within the xy plane that is divided as such. So 1, 2, 3, 4 in the counterclockwise direction. And so this question is asking for which of the following functions, which of the following quadratic functions, then the graph of it does not lie in the third quadrant. And so any parabola that passes through the third quadrant, whether it be this way, or maybe this way, all will pass through. And so we have to find a case in which it does not pass through the third quadrant. And so for this kind of question, you would have to graph each value. Uh, in actuality, if this kind of problem were to come out on the SAT exam, you can actually, instead of just drawing it on yourself on your scratch paper, you can just plug it into your Desmos calculator because your Desmos calculator actually has a graphical function that automatically draws the graph for you, uh, which is my recommended way of solving this question. If you were on the SAT, very quick and much quicker than just hand solving. But then we will still take a look at hand solving and how that can be done because it is just good practice for general mathematics. And so let's take a look at the first equation. And so you can, we first, uh, I would recommend you you could find the vertex and then also the solutions to get the most accurate version. However, for this question, you don't really need the vertex if you know the solutions. And so I will explain what I mean by that. But then first of all, we'll find our solutions, the of x values that are solutions to this function. And so we can set this quadratic function equal to 0. And so we can use either factoring or quadratic equation or the quadratic function. However, factoring is difficult, so we'll just use the equation itself so that x equals negative b, b being negative 4, so we get 4 plus minus root 16 minus 4 times a times c is negative 2 times 7, so negative 14 over 2a being negative 4. And so we can simplify this so as to get 6 root 72 over negative 4. Yes, that is correct. Okay, and so we can simplify the root itself so as to get 6 root 2 over negative 4. And so uh, just a bit more simplification, just to make things as easy as possible for ourselves. We can write it as 2 plus minus 3 over 3 root 2 over negative 2. And so from here, we can kind of we can generally draw what the shape of the parabola will be because our first x value, if the plus minus was a plus, then we get 2 plus 3 root 2 over negative 2, which will be a negative value. And so we don't need to know the exact point, but generally it will be around here. And so this will be our first x solution. And then if it was a negative, so 2 minus 3 root 2 over negative 2, the top part or the numerator is a negative value, because 3 root 2 is greater than just 2. Uh, and so it will be a positive value because we also divide again by a negative, so the negatives will cancel out. And so our second x solution will be here, -2. And then the important part is the direction in which the parabola opens up. Because the coefficient of the x squared value is a negative, the parabola will open downwards. And so we can say that the general shape will be roughly this. Then we can automatically say that no matter what the actual values or how close or how far the exclusions are or the vertex, there's always a point that passes through the third uh, quadrant within the xy plane. And so we can automatically say that A is a incorrect choice. Uh, we could go through each one, but then I feel like that will take a long time. So we'll just take a look at the solution now. And so Uh, the solution actually did a different approach utilizing vertexes. This is also a correct and a valid method. You can also utilize the X solutions that we found within the solution we just covered. And so we can see that uh, A and B have parabolas that open down, meaning there is always a part that lies in the third quadrant. And so this is true. So no matter where the vertex is, you can be here or you could be here. If the parabola opens downwards, there's always a part of the parabola that will eventually cross either both the third and fourth quadrant. Yeah, because the you can say the ends or the legs of the parabola spread outwards as the y value decreases further, meaning that eventually one leg will cross the third quadrant and the other leg will cross the fourth quadrant. And so from this fact, we can actually cross out A and B, and then we just have to compare C and D. Then we can see that if we did our method that we just did using X solutions and X intercepts, we will be able to find that either C was incorrect or that D was correct, depending on which one we analyze first. And so the solutions tells us that C is incorrect, and so the only correct answer that remains will be D. And so you could check this on your own time later to check if D is the correct answer by using any method that we just covered right now. But then, other than that, we can move on. And so we'll move on to our next concept regarding systems of equations involving quadratics. And so, if you remember, we did a lot of systems of linear equations, systems of some inequalities. This time we're doing systems of equations involving quadratics. And so it's always a similar concept. Systems of equations meaning you get multiple equations. So for our context, we get multiple quadratic equations. And then you can always find the intersection points by setting two quadratic functions equal to one another. And so we'll take a look at questions that utilize this concept. And so our example question states, how many points of intersection are there between the following two functions? And so large fx, capital Fx is equal to negative x squared plus 4x plus 9, while capital Gx is a linear equation, which equals to 5x plus 7. And so remember, you can always set these two equations equal to each other because these two always equal their y values. And so because they share a common y or a common fxgx, we can set these two equal to each other so that we get negative x squared plus 4x plus 9 is equal to 5x plus 7. And so you can move around everything to one side so that we get negative x squared. 4 minus 5 is negative 1, so negative x. And 9 minus 7 is plus 2, which will equal to 0. And so from here, we just find the x solutions to this quadratic function. So you could either factor or use the quadratic formula. However, I think we can use factoring for this one to change it up a bit. So we know that one x value will be negative, the other will be positive. And then from here, we can see that when it's added, it's a -1, and when it's multiplied, it's 2. So automatically you can think, okay, it will be either one of these two constants. So A and B can be 1, 2, 2, 1, uh, or they can be -1, -2, -2, -1. Because when they're multiplied, it has to be a +2. So the signs must be equal, the same signs for both values. And so you can kind of plug in and try out values, but then the correct one will be +2 and +1. And so uh, to be honest with you, this kind of factoring, wait, before we move on, I'll just check to make sure everything's correct. And so we'll get -x squared plus x minus 2x, so minus x plus 2. Yeah. And so this kind of factoring and quick factoring does come from just constant practice and constant experience regarding factoring, which I recommend you practice by plugging in values just randomly until you find the correct one, and then kind of remembering to always check for, okay, what sign, what value, when it's of the x coefficient it must be, and what the value of the product must be. And so I suggest practicing a lot of these questions to get used to it. And so, uh, oh, if we go back, then we can say, because we factored it out, we can now solve the question and say that uh, the solutions are x equals +1 and x equals -2. And so because we get two values of x for the intersections, we can say that there will be 2 points of intersection for between the two formulas. You can actually check this fact by drawing the equation itself. So 1 and -2, okay. 1 and -2. And so this one solution was 1, the other solution was -2. And the parabola will open up downwards in such fashion. Well, let me draw a bit better. Slightly slanted. So it will look like this. And then we can also, and the vertex, we can also write the vertex form very quickly. -4, so -2 squared, we'll get 4, -4 plus 13. And so the maximum will be a value of 13. And then we can also draw the linear equation. And so the y-intercept of the linear equation is 7. So we will write 7 here. And the x intercept will be -7/5. And so the linear equation will be look like something like this. And so automatically you can see that there's one intersection point on the right, and then there will eventually be another intersection point on the left. And so we can solve by graphing our equations so as to get see that there are two interceptions or intersection points. Uh, if, again, this kind of question was on the digital SAT, I would actually suggest you plug the equations into Desmos calculator so that it can graph it for you, and then you can actually check the exact intersection points that the Desmos calculator gives you. And so that is also a very valid and quick method of solving. And so we will, no, Srikar, do you have any questions regarding this problem?
No, sir, not at all.
Okay, great. Uh, Let me just check. Okay, so tips is to set the equations equal and simplify to a quadratic equation, and then use the discriminant to determine the number of solutions. Okay. So this is a concept that we'll cover in the next slides. Uh, this problem is very similar to the one we previously did, so I'll skip it for now, just to save time, and then maybe you could solve it on your own once I do send the PPT over. And so we move on to our final concept of this topic, which is discriminant and nature of roots. So the discriminant is the part of the quadratic formula that is this part. So the part that was inside the root, if you remember. And so the reason the discriminant part is very important is that depending on the sign and the value of the discriminant, we can find we can get information regarding the number of roots that exist for that solution for that quadratic function. And so if you take a look, if the discriminant or capital D is greater than zero, so a positive value, then we have two real roots. However, if D is equal to zero, we only get one real root. And then when in cases where D is less than zero, there are no real roots. And so another way of understanding this is that if we have a quadratic function or a parabola that looks like this, then you can see that there are two solutions because there are 2 points that touch the x-axis, and there is two x-intercepts. This is a case when the discriminant is greater than zero. And so there are two real roots. However, there are also equations that look and parabolas that touch the x-axis and then come back up, so that there's only 1 point of contact or one intersection. And so this is the case when the discriminant is equal to zero and there's only one real root. Again, our third example will be when the parabola doesn't touch the x-axis. And so this is when there are zero solutions. This is when the discriminant is equal to is less than zero. So you can memorize using this way as well. And so we'll take a look at example questions uh, that goes through this. And so we can see uh, oh, our example question being, which quadratic function has no real solutions? And so we can see we are given four quadratic functions, and now we have to find which one has no real solution. And so if you remember, for a function to have no real solutions, the discriminant must be less than zero. And so we'll find the discriminant because we remember the discriminant is equal to b squared minus 4ac, excuse me. Then we can just plug in values for b, a, and c to get discriminants. And so the discriminant value for a, function a, will equal b squared is 6 squared, so 36, minus 4 times a being 1 and c being 4. Oh, one moment. It's not 4 because it is equal to, if you take a look at the answer choices here, uh, they're equal to not 0, but another constant value. So we have to move these around so that we get 6x plus 9. And then the second equation we must rewrite as plus 2. Third equation we must rewrite as plus 5. And the fourth equation we must write as minus 9. And so knowing this, we can now find the actual discriminant values. And so the C value for equation A will be 9. And so if we take a look, it will equal to 36 minus 36, which is equal to 0, which it means there is one solution for equation A. And so equation A is not our function of interest because it has one solution, not zero solutions. And so we take a look at the next discriminant for equation B. This one will be b squared being negative
49 minus
7.
16.
Yes, that is correct. So it's 49 minus 16, which will equal 33. And so because it is a positive discriminant, we know that there will be two solutions to equation B. And so B is also not our choice of interest. Discriminant C will
9
equal,
plus 5.
yep, that is correct. 9 plus, not 5, but because we need to multiply negative 4ac. So we have to multiply negative 4 times negative 1 times 5. So we get plus 20. Yeah. And so we get 29. No worries, Circa. Easy mistake to make. Uh, and so again, it is a positive value. And so there will be two solutions. So C is also incorrect. And then our D value will be, for discriminant D, it will be equal to uh, b squared being 64, and then we multiply -4 times -2 times -9, which equals to 18 times -4, -72. And so 64 minus 72, it will be equal to -8. And so now we found the right discriminant, which is less than 0, so that we can say that answer choice D will have no real solutions and is the answer for this problem. Any questions, Ricard?
Not at all, sir.
Okay, great. Then we can move on. And so you can say, oh, excuse me, one moment. Yeah, no worries. And so we can say that, yeah, so that is our question. And so again, the solution is the same. And some tips is to calculate the discriminant to determine the nature of roots and to ensure the equation is in standard form before applying the formula. So just general tips for finding these kind of questions. And so uh, this one will be a very similar question. So I think we can skip this one. You can solve it on your own time, Srikar. But because of time sakes, I will move on to, just, I think we can go over this challenge question and then call it for a day for today. Uh, because I don't want to waste too much of your time because we are overtime technically. And so I'll keep it into 1 hour. Uh, so yeah, if we take a look at this problem, then we can see that the number of species X around the world is projected according to the following model of this quadratic function. So ST, or the population number of species X, is equal to -2t squared plus 4t plus 9, where S represents the number of species in thousands, so important units, while T represents the number of decades, so another unit of time, number of decades passed since January 1st to the year 2000. So from which year onwards will this number of species X drop below by 9,000? And so a lot of information, but then most important being the population equation. And so it is given to us in the form of a quadratic equation. And so this is the number of species numbers in thousands. And also we have to find the value of t in which the number of species x drops to below, so less than 9,000. And so we would have to find when this quadratic function is less than 9. Because each number is in thousands, we don't have to write 9,000, but just 9. And so from here, you can either solve with the inequality, or you can actually solve without the inequality, and just for easier solving, just put it as an equal sign. And then find a value of t that satisfies this quadratic function. And then we increase that t by one value so that the decrease will be greater than 9. And so I'll explain what this means further on, but then uh, yeah, let me just show you a graphical view of what this might look like. And so if the function was to look like this and a parabola that opens downwards, then, and we have to find a point here when the population is at 9,000, then there's two points. You can either be negative time or positive time. But then obviously, time cannot be negative, so we only focus on the positive side. And so the positive side will be at this point. And so we get a t value of, let's say, t1. And so this is at t1, the population will equal to exactly 9,000. But we need to find a uh, number of decades or number of years that results in under 9,000. So it has to be, our final answer will be a value that is slightly larger than t1. So maybe t1 plus 0.5, t1 plus 1. But then, so what I'm trying to say is that the t value we'll get from this quadratic function where we set it as equal to 9 will be t1. But then our final answer, we have to be at the end very careful. It has to be a value that is slightly greater than t1. And so that slightly greater value we'll check using these values here. And so if we understood that, then we can move on and solve the quadratic function now. And so we get uh, if we move the 9 to the left, then it will be negative 2t squared plus 4t, and plus 9 minus 9 will be 0. So plus 0 will equal to 0. And so fairly simple from here. You can actually simplify more by dividing the entire thing by 2 so that we get negative t squared plus 2t is equal to 0. And then from here, you can just group by t. So you can say t times parentheses negative t plus 2 is equal to 0. And therefore, t is equal to either 0 or 2. And so you can think that, okay, 0 does not make any sense. And it's also not a value that is within our answer choices. And so we take a look at the next value of, excuse me, the next value of t, which is 2. And if you remember, the unit of measurement for t was number of decades. And decades meaning every 10 years. And so if t is equal to 2, then after 20 years from 2000, so in 2020, there will be exactly 9,000 population for the species X. However, we need a value that is slightly greater. Okay, I see. And so at a year that is slightly greater than 2020 or time slightly later than January 1st, 2020, the species X will drop because it was a downwards opening parabola. The greater the t, the lower the y value. And so this is an important part where you have to read the question very carefully. So if you go back to the question, it says, from which year onwards will the number of species X drop below 9,000 species? And so the key word here was the word onwards. And so onwards meaning after. So what year after will this population be below 9,000? And we know that at exactly at 2020, it will be 9,000. And from 2020 onwards, it will be below 9,000. And so our answer will be choice A. And so, Srikar, do you have any questions regarding this problem? Okay, seems like not. All right, that's great. Uh, Srikar, I can ask you if you want to use a bit more time to go through our remaining challenge questions, or would you rather just stop our class here at 1 hour and then you can solve it on your own? Uh, no pressure, just whatever you would like. I'll listen to you.
I would like to continue this class.
Okay, no worries. Then we can continue to solve our remaining challenge
Sir,
question.
but I have a question, sir.
Yes.
Is my answer putting any stress on you, sir?
No, no, no worries. You don't have to worry about me. I have enough time to do more for the class, and so yeah, no worries. No worries. I'm perfectly fine with doing more. And so yeah, we can move on to our next challenge question for today, our second one. And so yeah, let's read the problem. The linear function fx crosses the origin of the xy plane, and a quadratic function gx is tangent at the point negative 2 comma 2. The linear function hx has a y-intercept at 0 comma 5 and is tangent to the quadratic function gx at point negative 3 comma 2. If gx is expressed as, oh, a bit of a formatting error. This 2 is a power of 2. Just remember that. And so negative x squared plus bx plus c. What is the value of b plus c? And so we're given three kind of graphs, two linear ones and a single quadratic. And so from here, you can see that we have to make use of the information given to us by the problem. And so you can see that fx, or this line here, crosses the origin and also is tangent to the quadratic function. Tangent meaning it comes into contact with. So it is there is a single intersection point between the linear function fx and the quadratic function gx, which is this point here. And this point is negative 2 comma 2. And so a similar thing happens with the linear function hx, where the y-intercept is 0 comma 5. Uh, I wouldn't think it will be too important, but then I'll still write it down. So in y-intercept being 5, and the other tangent point to the left of the quadratic is given to us as negative 3 comma 2. So we can write it will be negative 3 comma 2 on the left tangent point. And so this is all the information we're given, and we have to find the gx value, gx equation from here. So you might be confused as you can see that. So okay, how do I solve this? But just think of it very simply in terms of algebraics. And so if we were to write not fx but gx
So
as
can we write
expression,
that g of x can be substituted as g of negative 2 is equal to all of that equation, and all of that equation is equal to 2? Then we can substitute it for c, right, sir?
yes, that is correct. So that is a very valid method of solving. So like you said, we can plug in x value of negative 2. So g of negative 2 is equal to negative 4 minus minus 2b plus c is equal to the y value, which is the y value of the point being just 2. And so, like you said, Srikar, we can uh, re-express this equation to be a substitute for C. So we can say that C is equal to 2B plus 6. And so from here, we can plug it back into our original GX equation. If we were to do that, then we get a GX equals negative x squared plus bx plus 2b plus 6. If we were to do this, now we only have one variable b, and we also have another point that we can use. And so we'll use negative 3 comma 2. So we get 2 equals negative 3 squared is 9. So negative 9 plus minus 3b plus 2b plus 6. And so if we were to simplify this, we get negative b on one side, and on the other side, we get 5. So that we can say that b is equal to negative 5, and c is equal to, if we replace this b with negative 5, we get negative 10 plus 6, so negative
Negative
4.
4.
Yeah, no worries. Okay, and so because we got the two values for b and c, we can now add these together to get our final answer of negative 9. And so, yeah, it looked very confusing at first because it is very different from previous practice questions we solved until now. But it's very simple. It's actually slightly more easier than you can say that other like changing from general form to vertex form or finding solutions. And so, yeah, I think it's a great question as to not make sure to kind of learn you to not get intimidated if the question is slightly different from whatever you're used to, because most of the time the actual solutions themselves are still pretty simple. That's a characteristic of the SAT mathematics. So always just stick to the basics and what you know, and you'll be able to solve everything. And so, no questions for this one?
No,
Okay,
sir, not any.
great. Then we can move on to our final challenge question of today. And so, uh, I'll take a look at the solution. I think it might be slightly different. There might be an error for our final answer. Uh, so ignore that for now. We can take a look at it later. And another formatting error, but then I'll have to fix this. Just ignore it for now. It's not important. Uh, and so our final challenge question for today states, if y equals 2x squared minus 5x plus 3 and y is equal to 15, what is the product of the real solutions for x? And so similar to what we did before, we are given two pieces of information, one being the quadratic equation itself, another being when the y is equal to 15. And so, yeah, uh, okay. So first of all, because we kind of have a situation where y must equal 15, we set y is 15 for now. So 15 will equal 2x squared minus 5x plus 3. And so the question now asks for what is the product of the real solutions. If you remember, there's multiple ways to solve this. You can either find the solutions individually and then multiply them together, or if you remember our, I guess, form of a quadratic function, then we can see that the product of the real solutions is actually the constant part when the coefficient of x squared is 1. So we do the same thing for here, where we uh, have everything on one side of the equation. So 2x squared minus 5x minus 12 will equal to 0. And then from here, we divide everything by 2 so as to get x squared minus 5 over 2x minus 6 is equal to 0. And so if you take a look back at our characteristics of quadratic equations, the product of the equation is just the constant part when the coefficient of x squared is 1. And so we have the same solution, same situation. Coefficient of x squared is 1. And so our product of the solutions will equal this constant, or negative 6. And so our final answer will be negative 6. And so easier than the previous challenge questions we did, but then I included it just to make sure you're used to it, because it was actually a pretty common theme that pops up in a lot of SAT exams, especially regarding products or sums of solutions of quadratic equations. And so if you think of quadratic equation, this is a key part that uh, kind of always tends to come up, whether it be one or two questions. And so I want to make sure that you were used to it. And so take a look at the yeah, solution. Again, it's the same, so negative 6. And so this will be it for today's class. And so if we go all the way back, so that will be all for today's topic regarding quadratic functions. And so, yeah, I want to emphasize this topic a lot because it is a topic that is not only comes up as itself on the SAT very frequently, but then also it is a kind of algebra basic that we can later build up upon through future topics. And so I would recommend getting used to the topic and mastering the topic of quadratic functions. And so, yeah, that'll be all for today. I will see you on Tuesday regarding rational functions. And so, once again, as always, thank you so much for joining today's class. And if you have any questions, you can stay. If not, class is officially dismissed now. And so, yeah, thank you for joining, and I'll see you guys next time.